Welcome back to Smith Coding and Design. This is tutorial 4 in our Z-axis stepper motor mount. So let's go ahead and begin. We are into Op2 now. So if you remember, we probed the inside of our 1/4 inch tool and then we probed our parallel, and that gave us our WCS at the center bottom of our part. That's going to help us make sure all of our chamfers and our toolpaths line up perfectly for Op2 since we are using known geometry. All right, so now let's go ahead and begin, and I'm going to start with a 3D adaptive clearing, and we're just going to go ahead and get rid of most of this top hat of material. So I'm going to go to 3D, again, adaptive clearing. I'm going to go ahead and select my roughing tool. So I'm going to go to my Toolpaths library and select a 3/8 3-flute Gorilla chimp breaker. All right, we are at 7,500 RPM, 60 inches a minute. We are going to go into our heights tab. Since again it is a 3D toolpath, Fusion 360 will take the geometry into consideration for us. So all I'm going to do is go into my heights tab. And I do want stock top here, since our stock top in Op2 would be considered the top of our material, or that hat of material that is on what would be the top side of our part now after we flipped it. Now I do not want to go to the bottom of our part since we've already finished everything here. So what I'm going to do is go ahead and change this to model top. And then I'm going to go down just a hair, maybe 50 thousandths, just to make sure that we get past that top hat of material and clear everything away nice and smooth. Now we're going to go into the passes tab. Again, I'm going to go with somewhere around 10% diameter of the tool for the optimal load. So I'm going to go with 30 thousandths. So that looks good. Material to leave, I am just going to go with 10 thousandths. We do not need to enable smoothing or feed optimization. This is just a roughing pass or a roughing operation. So everything there is good. Again, we'll change our ramp clearance height to 20 thousandths instead of 100 thousandths, just so when we enter this hole in the center here, we wouldn't be cutting air. So let's go ahead and click OK. Fusion will take a minute to generate our toolpath so it looks nice and smooth. One thing I'm noticing here is it doesn't look like we went down far enough to finish or to remove that top hat of material, and I think I know why. Again, that's why we always simulate. So if I go back in here to the heights, I actually wanted to go minus 50 thousandths. So I wanted to go below the top hat of material by 50 thousandths and then start removing. So let's click OK. And now let's look at our simulation again. And we'll just go ahead and use the timeline here. So again, we're just walking our way around. And again, I'm just slightly below the top hat of material just to make sure that I am removing everything and not leaving any type of thin skin. So if you simulate and you ever see, some material here that looks like you're leaving tin foil behind, just go down below the top hat of material by, 50 thousandths, just by a little bit, and you should be able to get rid of that. All right, so there we go. We'll just continue walking around. And there we go. We did that helical entry there in the center, and that's where our ramp clearance height comes in, so we don't cut air. We just start 20 thousandths above the hole, and then we go ahead and we clear everything else, leaving just enough material for us to do one pass with a Superfly and get that flawless surface finish. All right, so I'm going to escape there. Now what we do need to do is we need to go ahead and finish the inside pocket here where our motor mount meets to the stepper motor. So that's what we're going to do next. So I'm going to go ahead and go to 2D contour, and I'm going to select my finishing tool. Again, you could select it from here, or you could go back to your library. These are the tools we've already used, so I'm just going to go ahead and select it from here for now, just to save us some time. And we are at 7,500 RPM, 30 inches a minute. Let's go into geometry. And again, we want to finish the pocket here where we meet to our stepper motor. So that's fine. We go into our heights. Again, we've removed all the material from the top essentially except 10 thousandths. So for the starting height, I'm just going to choose model top. And again, it's not a big deal since we are just going into this pocket where we've already removed pretty much all the material away. So what I'm going to do now is go into our passes. All right. And so I'm going to click OK here in a second. I think we may need some roughing passes since this is a larger diameter pocket. So what I'm going to do first is go ahead and click OK. We'll do smoothing and feed optimization. And again, if we were worried about the tolerance or how tight we were fitting that stepper motor, we could change from in computer to where. That way we could use the tool diameter and compensate for that in Path Pilot. So what I'm going to do now is just go ahead and click OK. And then we're going to simulate, and we're going to see if we need roughing passes to see if we really do indeed finish the floor and the sidewall. So let's go ahead and go to simulate. Going to use the timeline here at the bottom. And it looks like we do indeed get all of the material without needing any roughing passes. So that is a good deal, and that we're barely able to do that. So I think if the diameter of this pocket was just a little larger, we'd need at least one roughing pass to make sure that we were able to again remove all the material from the floor and from the sidewalls. It's kind of an ugly angle, so we'll go back to our home view. And so what we want to do now is we want to go ahead and face off the top of our part. So that's what we're going to do next. All right, so we're going to go to 2D face. Again, I'm going to go ahead and select the Superfly. We're just going to use it from here instead of going into the tool library, just to make it a little simpler. 2000 RPM, 15 inches per minute. Okay. So it's the same thing we did in Op1. Our geometry's fine. Now our top height, we removed all the material from the top of the part. So I'm actually going to change this to model top, and we left 10 thousandths worth of material on top of the part. So I'm going to go 10 thousandths above the model top. So we're 10 thousandths. So we're going to remove all the material 10 thousandths above the model top to the model top itself. So that's fine. We should be able to do that in one pass. Again, I'm going to make the step over 3 inches so that we are centered and we remove all the material in one pass. We're going to go to climb. We don't need multiple depths, and we don't need stock to leave again since there's only 10 thousandths. And we'll just go ahead and extend before retract and click OK, and that should go ahead and again just in one pass centered in the center of our part. So let's go ahead and simulate. One pass right down the center. Give us that nice mirror finish. There we go. Perfect. So now all that we need to do is go ahead and do the chamfers on the back side, and we are done with our part. So with that being said, let's go back to our home view and then let's go through the chamfer. So I'm going to go to 2D chamfer. And again, for the tool, I'm just going to use the previous 1/4 inch Gorilla Tool Lemur chamfer. I'm going to select OK. And then I'm going to go into the geometry here in a second. But for the speeds and feeds, we're at 4,000 RPM, 20 inches a minute. And now I'm going to go ahead and select all of our contours. So we want to do the outside of the part. We want to get all of the holes for our M3 mounting screws. We want to get the upper contour around the center pocket, and we also want to get the contour around the hole in the center. Okay, so for our top heights, again, I'm just going to select model top since we've removed all the material from the top surface of the part. And then what I'm going to do now is make my chamfer, again, 15 thousandths. And then let's see if we can make the chamfer tip offset 60 thousandths. And really you want the offset to be as large as you can while still staying within your flute length. Go ahead and enable smooth and feed optimization, and we will approach at 45 degrees. And we'll click OK. And now what we'll do is we'll go ahead and simulate. All right, that all looks good. And you'll notice that we did not chamfer the holes here where the M3 mounting screws go through. And so let's go back and look at what we forgot to do. It might have been that our chamfer tip offset was too large. Let's see. Let's go to geometry. So we did select them in geometry. So I think the problem is going to be that our chamfer tip offset is too large. So what I'm going to do is go ahead and back that off just a little bit. Let's see if, you know what, let's just go back to 40 thousandths and that should do it. There we go. So now if we simulate, you'll notice that we do indeed go ahead and chamfer the holes for the M3 screw. Now another thing that I could have done is I could have duplicated this and then did the outside around the part and the M3 holes separately. So in fact, let's just go ahead and do that. Let's go ahead and duplicate the toolpath. We'll go into the first one here. We'll go into our geometry. And let's go ahead and just get rid of all of our selections. And we're just going to get the larger diameter circles and the outside of our part. And then let's just go ahead here and make our chamfer tip offset 60 thousandths. And then what we can do is just do the M3 holes separately. So let's go ahead and do that. Let's go into our geometry again, and this time again we're just going to clear everything and then select the M3 holes. And then for our passes, again, we're going to leave that tip offset at 40 thousandths so we can actually get in there and chamfer those holes. We're going to click OK. And then there you go. It's not a big deal since we are using the same tool. There won't be a tool change needed, so we'll transition between the two tool paths smoothly, and we'll get a nice chamfer around the outside, and we'll get nice chamfers around those M3 holes. So that finishes off the part, guys. I hope you enjoyed. Again, we will go through the machining now on the Tormach. And that does it for this tutorial series, and I'll see you guys in the next one. Please like and subscribe. Alright, so here we come in with our 3D adaptive clearing. We're using a 3/8" Gorilla chimp breaker end mill, 60 inch per minute, right around 400 thou depth of cut, and our optimal load is 30 thousandths, or a width of cut of 30 thousandths if you want to look at it that way. Again, we're just walking around the outside contour of our part, then we'll do a helical entry into the center and just clear away all of the material except 10 thou on top. And then we'll take a single pass with the Superfly after we finish the inside pocket, just to get that nice smooth surface finish. So bear with me here, the toolpath is quite lengthy. We're just going to jump through some of the cool highlights in the toolpath, and then what we'll do is we will start transitioning to our 2D contour, where we will take a 3/8" 3-flute Gorilla Silverback end mill, and we will finish the inside pocket where the mount meets to the stepper motor. Alright, so now we face the top of our part using the Tormach Superfly, 15 inches per minute, 10 thousandths depth of cut, and 40 millimeters, which is the entire width of our part for the width of cut. So that's it for the Superfly. Again, just going nice and slow, trying to get that mirror surface finish. Alright, so now we finish up our part by just going ahead and chamfering all of our edges, making sure there's no sharp burrs. We're going 20 inches per minute using a 1/4" lemur chamfer mill by Gorilla Tools, and just leaving a 15 thousandths chamfer again around all of the edges of the part. Thanks for tuning in. Please like and subscribe, and I'll catch you guys in the next tutorial series.